The performance and life of a Mack engine depends on the air it breathes. So in this video, we'll review the operation, maintenance, and troubleshooting of the current Mack air intake system. The chassis-mounted charge air cooler, or CMCAC system. This includes covering the air cleaner, turbocharger, chassis-mounted charge air cooler, and intake system piping. So let's get started by looking at the air cleaner. All Mack air induction systems have an air cleaner assembly that's designed to remove dust and dirt from the intake air before it enters the engine. This assembly usually consists of two main parts, a housing and a replaceable dry filter element. To clean effectively, all the incoming air must pass through the paper filter material in the element. And to make sure that happens, seals on the filter or in the housing prevent any incoming air from bypassing the element and allowing unfiltered air into the engine. Initially, the filter material traps particles as small as 25 microns. However, with use, the dust and dirt that accumulate on the paper actually improves its filtering ability. That is, up to the point when it accumulates so many particles that it becomes too restricted for further use. Airflow through the filter can be either from the inside out or outside in. RD models use the inside out approach. Incoming air first enters the center or inside of the filter element, then passes through to the outside of the filter before entering the engine. On CH and CL models, the airflow is reversed, or outside in. Incoming air first passes through the outside of the filter element, then to the inside or center of the filter before entering the engine. To determine the correct time to replace the air filter, you first have to keep an eye on the air filter restriction gauge that's mounted in the cab or on the air cleaner housing. This gauge measures the amount of vacuum present in the air cleaner housing. As the filter becomes more and more restricted, vacuum increases. When the gauge indicator enters the red zone or shows 25 inches of water, it usually means it's time to replace the filter. However, water vapor in the air or condensation buildup on the filter paper can cause a temporary restriction that results in a false gauge reading. If you think this might have happened, reset the restriction gauge. Then drive the truck at full load and at rated speed for a few minutes. If the filter really needs to be replaced, the gauge indicator will be in the red zone or show 25 inches of water. If not, the gauge will show the actual restriction caused by the filter. Two important notes here. 1. Do not remove the air filter for a visual inspection. Appearance is not an accurate gauge of a filter's need for replacement, and removing it only increases the risk of dirt entering the induction system. 2. However, even if the restriction gauge doesn't indicate it's needed, always replace the air filter and any seals at least once a year or when the truck is driven 100,000 miles, whichever comes first. Next, if you come across a restriction gauge that doesn't seem to be showing an increase in vacuum as the truck is being used, do the following. Check that the filter element is not torn or punctured, and that the seals are not missing or damaged. Then remove the restriction gauge or the hose to the housing. Make sure the filter below the gauge isn't clogged by blowing air through it. If it's blocked, clean or replace it as necessary. Next, test the restriction gauge itself by applying vacuum to it directly. If the gauge does not measure the correct level of vacuum, replace it. On in-cab restriction gauges, also test the hose to the gauge for leaks. Do this by applying a vacuum to the hose. If the vacuum bleeds down, you know the hose is leaking and should be repaired or replaced. Take a break now to review what we've covered so far. To install a new filter element in a Mack truck with this type of air cleaner housing, begin by wiping off all of the dust and dirt from the housing. Then unclip and remove the filter element. Inspect the housing and element sealing areas for dirt tracks, which indicate leakage past the seals. Then discard the old filter. Do not attempt to reuse an old filter by cleaning it with compressed air or by banging it against something to remove the dust and dirt. These practices damage the filter paper and seals and allow unfiltered air into the engine. Clean the inside of the housing with a damp cloth or vacuum cleaner and carefully inspect it. If the housing is damaged or rusted, particularly in the filter sealing areas, it must be repaired or replaced before you install a new filter. See the Mack Maintenance and Lubrication Manual for detailed instructions on removing rust and repainting the air cleaner housing. Next, inspect the replacement air filter element. Make sure you're installing a new Mack-approved filter element. Elements that aren't approved may use seals of the wrong size, or a paper material that doesn't trap particles as well, both of which mean possible engine damage caused by the dust and dirt in unfiltered air. Check the element for damage due to mishandling. If it's okay, install the new air filter element and secure the air filter cover on the housing. With this type of air cleaner housing, the procedure to install a new filter is similar. After removing this cover assembly, lift the element out of the housing. Clean and inspect the housing. Then be sure to replace this seal before installing a new filter element. Next, replace the cover and rain shield assembly. Torque the cover retaining nuts evenly to 8 to 10 foot-pounds. Do not over-tighten them. Over-tightening can distort the housing or damage the filter element and cause leaks. The next component in the intake system that we'll look at is the turbocharger. This precision-manufactured device uses the normally wasted heat energy in the engine exhaust gas to drive a turbine wheel. This wheel connects via a shaft to a compressor wheel. As the exhaust gas turns the turbine wheel at speeds which may reach 100,000 RPM, the compressor wheel draws air past the air cleaner, compresses it, and forces the resulting pressurized air through the rest of the induction system. This increases the efficiency of the engine by packing more air into each cylinder for combustion. This allows more fuel to be injected into the cylinders also, resulting in more power, greater torque, and better fuel economy without increasing the size of the engine. With the high heat, precise tolerances, and fast turning speeds, a turbocharger requires both clean air and clean oil to survive. So every scheduled maintenance includes inspecting the air cleaner restriction and intake ducts, checking the turbocharger, and looking for turbo oil leaks, and torquing the turbo mounting bolts to specification. The engine must also be operated properly to prevent turbo bearing damage caused by a lack of oil. When the trucks first started, the oil pressure must be allowed to reach at least the normal minimum pressure for the engine in the truck before being run at high speed or under a heavy load. This allows a sufficient flow of oil to the turbo bearings. Likewise, after the truck has been operating, the engine should be allowed to idle for 3 minutes before shutting it down. This allows the turbo wheels to slow down and the engine oil to cool the unit, so that once the engine is off, the oil remaining in the unit will provide sufficient lubrication until the turbo wheels stop rotating. At 150,000 miles, or 4,500 engine hours, a tune-up maintenance is required that involves checking the turbocharger this way. Clean the outside of the turbocharger. Then remove the exhaust and air intake pipes from the unit. Inspect the turbo housings and wheel blades for damage and excessive dirt buildup. Look for oil leaking from the bearing housing in the center of the unit. Check that the wheel blades don't rub against the housing while pushing the shaft in various directions and turning the wheel. Also, spin the wheels to be sure the shaft doesn't bind. Any binding, wheel to housing rubbing, excessive dirt, or damage means the turbo must be removed and replaced. Take a break here to Unless you find the type of turbo damage we described previously, it can be hard to determine when to remove a turbocharger for replacement. The fuel system, engine, exhaust system, cooling system, and the induction system from the air cleaner to the turbo may all be the source of a problem that shows up as a symptom with the turbo. If you find yourself in this situation, one quick way to decide whether the turbo should be removed is to measure the axial and radial end play of the turbine shaft. We'll cover measuring the axial end play first. With the ducts on the turbocharger removed as shown, set the needle of a dial indicator on the center of the compressor wheel nut and preload the indicator needle. Pull the turbine wheel all the way back and zero the gauge. Then push the turbine wheel all the way in toward the turbo and note the reading on the gauge. Compare this reading to the specification for the turbo, and if it's out of spec, remove and replace the unit. Checking the radial end play is a little different. First, to access the turbine shaft, remove the oil inlet tube to the turbocharger. Then, using the appropriate adapters and extensions, set the needle of the dial indicator on the center of the turbine shaft. Push down equally on both turbo wheels before zeroing the dial indicator. Then push up equally on both wheels and note the reading. Once again, if the reading is out of specification, remove and replace the unit. If you're going to leave the turbocharger installed, however, be sure to pre-lube the shaft with clean engine oil before reinstalling the oil inlet tube. If the axial and radial end plays are within spec, but you still have other conditions that lead you to suspect the turbo's the cause, particularly the presence of oil in parts of the turbo, you'll have to evaluate these symptoms carefully. See the video reference guide for this program for detailed information on possible causes of specific turbocharger symptoms. Generally, however, you should not replace the turbo unless there's an excessive exhaust smoke, excessive noise, oil leakage, oil consumption, or low power complaint. And before replacing a unit, always check the following. Look over the fuel system and make sure there are no restrictions or leaks in all lines and fittings. Make sure the engine oil is at the proper level and not contaminated, and that the oil pressure is correct. Also, check the crankcase breather tube for clogging or restrictions. Ensure that the coolant is at the proper level and the cooling system is working properly. Make sure the air induction system is not damaged or restricted. There will be more information on how to do this later in this video. Inspect the exhaust system for leaks and restrictions. If you find a problem in any of these areas, correct it and do a road test to see whether the smoke, noise, oil, or power symptom goes away. If it doesn't, check the information in the video reference guide. It may be time to replace the unit. After removing a turbo for replacement, you should do some failure analysis on it. This is cheap insurance against damage or failure of the new turbo. Failures usually fall into one of three categories: overheating, insufficient or contaminated lubrication, or mechanical damage. But first, after removing the unit, check for oil and excessive carbon in the exhaust manifold and turbine inlet. This usually means there's an engine problem that is not related to the turbocharger. However, this could also occur if there is severe oil leakage from the turbine shaft seals. If you don't find the turbo oil return tube blocked or restricted, it's likely the engine's the problem, not the turbocharger. Take a break here to review what we've just covered. Overheating damage usually takes the form of erosion of the center wall of the turbine housing, a burned gasket, discoloration of the turbo housing, or flaking of the housing. Coking of the oil inside the turbo oil inlet or outlet, or in the inlet and outlet tubes, means the turbo lubricating oil is being overheated. This can be caused by some restriction in the oil outlet tube that prevents the free flow of oil through the unit. Clean out or replace any blocked or restricted oil tubes. Also, check for a restricted intake airflow, incorrect pump timing, an overfueling condition, or restricted exhaust system. Insufficient or contaminated oil damages the turbo bearings, but doesn't usually leave signs of overheating. A sure sign that this type of damage has occurred is when you find wheel-to-housing rubbing, or when the radial and axial clearances exceed specifications. Check the maintenance record for the truck to be sure the engine oil and filters have been changed at the right times. Be sure the oil filters aren't clogged and that they're the correct ones to use. Also, make sure the correct oil's being used before installing the new turbo. Mechanical damage ranges from the disastrous to the slight. Slight erosion or rounding of the edges on the compressor wheel usually means dust particles are entering the induction system. These types of leaks must be sealed. Heavy damage, like this to the compressor wheel, indicates there was some foreign object that got into the induction system and found its way to the turbo. Check the system piping between the air cleaner and the turbocharger. Remove any foreign parts or particles. Damage to the turbine wheel, on the other hand, indicates internal engine damage. Repair the engine before installing a new turbo. In addition, whenever there has been a turbocharger or engine failure, the charge air cooler must be flushed to remove all debris and oil which could cause an engine runaway. We'll review the proper techniques for flushing a chassis-mounted charge air cooler later in this video. To correctly install a new turbocharger, clean the mounting area on the exhaust manifold. Remove the turbo oil outlet and inlet tubes. Check the tubes and any oil fittings for damage, restrictions, or oil coking. Clean the parts you are going to reuse and replace any that are damaged. Install a new gasket on the manifold. Then install the turbocharger. And torque the mounting bolts to specification. With a new gasket in place, install the oil drain tube. Using the chassis-mounted cooler inlet tube as a guide, align the compressor housing on the turbo and put the band clamp in place. Torque the compressor housing band clamp to specification, then install the exhaust duct. The next step is vitally important to the life of the new turbo. Pre-lube the turbocharger bearings by adding 1/2 pint of clean engine oil at the oil supply inlet fitting. With a new O-ring installed, assemble the oil inlet tube on the turbo. Install the air intake duct on the compressor inlet. And torque all fasteners to specification. Remember, failure to pre-lube the bearings will result in turbo bearing failure. Take a break now for review. The next part of the induction system that we'll cover is the charge air cooler. The charge air cooler is the part of the intake system between the turbocharger and the intake manifold. For this reason, it's sometimes also referred to as an intercooler or aftercooler. It's needed because the turbocharger heats the intake air as it compresses and pressurizes it. You'll get the idea of how this happens if you notice how much hotter the tube on a hand bicycle pump is after you've pumped up a tire. The problem is, hot air takes up much more space, is lighter, and less dense than cooler air. So, to get the full benefit of pressurizing the air, the charge air cooler cools it down and makes the resulting intake air much denser, which means it contains more oxygen for more efficient combustion and greater engine power. The chassis-mounted charge air cooler works just like a radiator, except turbocharged air flows through the tubes in the assembly rather than engine coolant. With this part of the inlet header tank removed, you can see how the turbocharged air flows into the tubes from one side of the cooler to the other. The outside air that's pulled through the cooler by the engine fan or pushed through as the truck is moving cools the hot turbocharged air on its way through, typically from a temperature of about 325 degrees Fahrenheit down to 110 degrees Fahrenheit. The chassis-mounted charge air cooler requires periodic maintenance and inspection. Every day, all bugs, leaves, and other debris should be removed from the front of the cooler core. Then, at the correct maintenance intervals, check the welds joining the header tanks to the core of the cooler for cracks. Check the condition of the mounting bolts and brackets. The brackets should not be cracked or damaged, and the bolts should be tightened to 30 foot-pounds. Also, check the cooler's cold fins for external damage, corrosion, or blockage with dirt or other debris. Remove fin blockage by blowing compressed air through the core from the back to the front. And use a firm fiber or plastic bristled brush, not a metal wire brush, to remove any corrosion. There are also 2 tests you can do on the cooler if certain performance problems lead you to suspect it's the cause. One is a restriction test to check whether dirt or other debris is reducing the internal airflow through the cooler. The other is a pressure test to check for leaks. To pressure test the core, disconnect the outlet and inlet piping at the cooler. Seal the core inlet with a plug designed for that purpose. And securely tighten the clamps to hold the plug in place. Install another plug that's connected to an air pressure gauge and a shutoff valve at the core outlet. Again, clamp this plug securely. With the air supply off, connect an air line that includes a pressure regulator to the core outlet plug. Stand clear of the plugs on the cooler before opening the pressure regulator to apply 30 psi to the cooler. Shut off the air supply. Check the gauge for any pressure drop that might occur. Pressure should not drop more than 5 psi in 15 seconds. If it drops more, the charge air cooler is leaking excessively and must be repaired or replaced. Take a break here to review. A quick way to find the point where a cooler is leaking is to pressurize it again with 30 psi of air and then spray a soapy water solution on the cooler surfaces. At any spot where the cooler starts blowing bubbles, you know you have a leak. Not all damage or leaks in the cooler can be repaired, however. Refer to this chart in the CMCAC section of the E7 engine manual for information on what type of cooler damage can and cannot be repaired. Generally, if you find damage that blocks or restricts turbocharged air from flowing through a tube, separated internal fins, excessive external fin damage, or tube cracks or separations that exceed 1/4 inch, you should replace the cooler. On the other hand, a few bent cold fins can be straightened using a small screwdriver or needle nose pliers. but most other types of damage require TIG welding for a proper repair. This includes things like header tank to core separations, header tank cracks, and tube cracks or weld separations that exceed 1/4 inch in length. Again, see the CMCAC section of the E7 engine manual for welding specifications. An easier repair that works only on tube cracks like this, that don't exceed 1/4 inch in length, involves sealing the crack with RTV. The procedure for making this type of repair is also in the E7 engine manual. Be sure to follow all steps in this process, particularly in the areas of cleaning and preparing the surface, priming, and applying the RTV mixture. And before installing a repaired or new cooler, always pressure test it before installing it on the truck. The cooler restriction test should be done this way. Connect pressure gauges to the outlet and inlet piping for the cooler. Many Mack trucks are equipped with connections for these gauges on the inlet and outlet cooler tubes, as shown in this top view diagram. You can install connections for these gauges yourself by drilling holes in the proper places on the tubes and welding connecting nuts in place. Or you can install replacement inlet and outlet tubes that are already equipped with these connections. Mount the gauges where they can be seen easily while operating the truck. Then run the engine at full load and rated speed and note the readings on the gauges. If the readings differ by more than 4 inches of mercury at full load and rated speed, the charge air cooler is restricted. It may be possible to flush the cooler to clear the debris that's restricting the airflow through it. This should be done after any turbocharger or internal engine failure. Remove the cooler and use a safety solvent as the flushing agent. Do not use a caustic cleaner like sodium hydroxide. Handle the cooler carefully to prevent damaging it. Shake it vigorously to dislodge any large particles. Then pour out and properly dispose of the used solvent. Wash the cooler out with hot soapy water. Rinse this solution out with clean water. If you suspect any oil, dirt, or dust might still be in the cooler at this point, repeat the flushing process until you're sure it's clean. Then blow the core out with compressed air flowing from the outlet to the inlet side of the cooler. Remember, any oil left in the cooler can cause an engine runaway. After reinstalling the unit, test the amount of restriction again. And if it's still too high, replace the charge air cooler. Take a break now to review what we've just covered. The intake ducts and pipes are an integral part of the air induction system that should not be taken for granted. They provide the connections between all the other components, tying the entire air induction system together. And like other parts of the induction system, these also must be inspected periodically. Begin by looking for cracks and breaks, particularly where the ducts are clamped to another component. When you're looking for this type of damage, remember that you'll see different signs of damage in different parts of the induction system. For instance, because the turbocharger pulls air from the air cleaner to its compressor wheel, you may see small dirt tracks on the ducts that indicate unfiltered air is entering the system. From the turbocharger on, the system is pressurized. So if you see a spot that's much cleaner than the area that surrounds it, this may be where pressurized air is escaping. Also check these components for any dents that might restrict airflow. Since contact between parts, coupled with the vibration of the truck, could wear holes in the intake ducts, reposition, if possible, any duct that might rub against another part. And move and secure any other lines or hoses that could rub against them. Make sure the ducts mate correctly with any hoses. Most molded tubes and elbows have a bead which shows the correct engagement length. Make certain the hoses overlap the ducts up to these gauge marks. If you can't find any gauge marks, the hose should overlap the duct by at least 1 inch. The hose clamps must also be positioned correctly. On the charge air cooler, make sure the springs on the clamps are positioned underneath the hoses to avoid interfering with and damaging the hood when it closes. Tighten these clamps until the spring is fully compressed. Then check the torque on the nut to be sure it's tightened to specification. In areas where only one hose clamp is used, the clamp must be positioned 1/4 inch from the end of the hose. Tighten this type of heavy-duty hose clamp to the specified torque. Do not over-tighten any hose clamps. This can deform or crack an intake duct and cause leaks. If you suspect a leak in the induction system and a careful inspection doesn't indicate where it is, you can leak test the entire system. This requires sealing the induction system. To do this, close off the air cleaner inlet with a heavy gauge plastic and several layers of duct tape. Clamp this cover securely over the inlet. If equipped, plug the drain hole in the air cleaner assembly with duct tape. Block the turbocharger exhaust outlet in the same way you sealed the air cleaner inlet. With the air supply off, connect an air line that includes a pressure regulator and gauge to the intake manifold. Then slowly pressurize the system to a maximum of 5 psi. As you did with the charge air cooler, apply your soapy water solution to the ducts and all hose and duct joints. If bubbles start forming at some point, you know you've found a leak. And after making any needed repairs, leak test the system again before putting the truck back in service. Take a break here to review. Problems with the air induction system usually first show up as engine power or excessive smoke complaints. And if the cause isn't immediately obvious, the first thing you should do is gather all information possible from the driver about the specific complaint, particularly the driving conditions that exist at the time the problem occurs, the pyrometer reading, coolant temperature, oil pressure, and the color of the exhaust smoke. Next, you need to hook up some gauges and take the truck for a test drive. Connect a boost pressure gauge and hook up an exhaust pyrometer if needed. Reset the air restriction gauge and adjust a mirror to see the exhaust smoke while driving. Locate the gauges where you can see them easily while driving. Then hook up a fully loaded trailer and check the exhaust smoke as you drive the truck through its full range. Record the other gauge readings with the engine under full load. This chart in the CMCAC section of the E7 engine manual covers the probable causes for induction system problems based on boost and pyrometer readings. For instance, if the boost pressure is normal, but the pyrometer temperature is high, look for something obstructing the outside airflow through the charge air cooler. If the boost pressure is low with a high pyrometer reading, check first for restrictions in the system from the turbocharger to the air cleaner. Then check for dirty turbo wheels. Finally, look for leaks in the pressurized side of the induction system, including the intake manifold and charge air cooler. With just a general low power complaint, check the charge air cooler tubes for obstructions. Then perform a restriction test on the cooler. On trucks with a charge air cooler bypass system, also make sure the bypass valves work correctly with the engine at operating temperature. Excessive exhaust smoke complaints must be evaluated based on what's normal for the truck. For instance, black or gray smoke under heavy load conditions is normal for some engines, particularly those without VMAC. White smoke is normal when a truck is first started and is usually worse the colder it is outside. This smoke is often caused when water that has condensed in the exhaust system evaporates as the exhaust system heats up. Blue smoke, though, under any engine operating conditions, is a sure sign of a problem. The blue color usually indicates that the engine's burning oil. Where the oil's coming from is the question. It could be as simple as the engine being overfilled with oil, or a clogged crankcase breather tube. As far as the induction system is concerned, look for oil on the turbocharger compressor wheel or on the compressor housing that indicates damaged turbo bearings or a turbocharger seal failure. If you find oil on the turbine wheel or in the turbine housing, remember that engine damage, such as worn valve guides, worn piston rings, or liners, or damaged or worn pistons, as well as a damaged turbocharger, could be causing the problem. Excessive black or gray smoke is usually caused when the engine's air-fuel ratio is too high, the black or gray being unburned or partially burned fuel. Generally, this is caused by the engine being overfueled or the air induction system being restricted and not allowing enough airflow for complete combustion. Typical problems in the induction system that could cause this include a clogged air filter, restricted or collapsed air intake piping, a clogged charge air cooler, or a dirty or malfunctioning turbocharger. Other causes beyond the induction system include an inoperative or misadjusted puff limiter, leaking injection nozzles, a restricted exhaust system, a restriction in the fuel return lines, and a misfiring cylinder. White or bluish-white exhaust smoke at normal engine operating temperatures often means a coolant leak into one or more of the engine cylinders. It usually doesn't indicate that anything's wrong with the induction system. Likely causes of this symptom include a blown head gasket, a cracked cylinder head or block, or damaged cylinder liners, or liner seals. As you've seen, the operation, maintenance, and troubleshooting of a Mack air intake system is not all that difficult, but it is vitally important to the life and performance of the engine. All the components in the system work together. So whether it's a hose or hose clamp, or the turbo, or cooler, all parts of the system must be maintained carefully and inspected periodically. Downtime caused by a faulty induction system is one of the easiest problems to avoid. Don't let something as simple as a dirty air filter cause major engine damage. Take a moment here to review these important points from the final part of this tape.